All right. So now we're going to use our trigonometric identities to continue factoring, continuing simplifying. And one strategy and technique that we're going to need to get pretty comfortable with when we are verifying trigonometric identities is to know how to factor. So right now, just to be very clear, I'm not necessarily trying to get this to be in quote unquote the simplest form. I'm just trying to practice factoring right now. That's my goal, just to practice the factoring. And I've given you a couple of techniques up here. Try factoring out the greatest common factor, trying to apply something like the difference of squares, knowing how to factor trinomials, and rewriting them in quadratic form. And then also remembering how to factor by grouping. That often happens when we have four terms. But let's just go through a few of these problems, right? Right now, again, make sure you understand that the focus is factoring, not necessarily trying to get it in the simplest form possible. So let's identify here. In number one, do I have anything that I can factor? And the answer is yes. I see a sine x here and a sine x here, right? You can even imagine if sine x were equal to something like a and cosine x were equal to something like b, I could temporarily just rewrite this like this. And if you were in a pre-algebra or algebra 1 class and someone asked you to factor this, you would know that you could just rewrite this as 1 plus 2b. And if we plug back in our trigonometric functions, that would just simply be sine x times 1 plus 2 cosine x. Now, do we have to do any of this stuff with the substitutions? Completely optional. It's completely optional. Completely optional. That is just to help us see the structure for factoring here. All right, just wanted to make sure that we're clear on that. All right, let's go ahead and look at something like this. So for number 2 now, if I wanted to factor this here, hopefully you see that we have sine squared x that I could factor out, and we're left with 1 plus tangent squared x. Okay, if all I need to do is factor, I'm done. Okay, we are done. However, if I wanted to simplify, if simplifying, ask yourself, how can I simplify this? Well, I've got sine squared x, 1 plus tangent squared x. Check your identities sheet if you don't have it memorized by now. But 1 plus tangent squared x, hopefully you see that that is equal to secant squared x. And sine squared x, well, what is secant squared x? That's 1 over cosine squared x, which we can then write as sine squared x over cosine squared x, which then can be rewritten as tangent squared x. Okay, so if we wanted to just simplify, that's what we would write there. Okay, all right, let's keep going with these. And if you want to just keep trying these on your own, feel free to just do so, but I'll work through these. 1 minus sine to the 4th x. Well, okay, for something like this, which by the way, actually we're all right. So 1 minus sine to the 4th x. Well, hopefully if you saw something like a minus, well, actually, no, let's not do that. Actually, if you really thought about this kind of structure here, you could rewrite this as a difference of squares, right? This would be equal to, let me just move this over to the side. This would be equal to a squared plus b squared times a squared minus b squared. So we can apply that same principle here. So we'd write this as 1 plus, what is my quadratic or my perfect square here? Sine squared x times 1 minus sine squared x. And if we wanted to factor all the way, if we're being really kind of thorough here, we'd write this as 1 plus sine x times 1 minus sine x. And wasn't really able to fit that all on one line. Sorry about that, but it should be this. Okay, oops, close that parentheses. All right, so again, we're not really worried about doing any simplifying right now. We're just trying to factor as much as we can. All right, let's go on to number 4. Number 4 is probably an easier one. This is just the difference of squares. So secant theta plus 1, secant theta minus 1. Okay. This is what we would get if we were factoring. Again, if we were trying to simplify, hopefully you see that secant squared theta minus 1 using a Pythagorean identity would just be equal to tangent squared theta. Okay. Number 5, all right. That one looks a little bit more complicated. And at first glance, we can't do any factoring here. But perhaps if we can rewrite some of these trig functions using identities, we can then have something that is factorable. So cosine squared x using a trigonometric or Pythagorean identity, we can write as 1 plus cotangent squared x. And we're left with minus cotangent x, minus cotangent x minus 3. So we can rewrite all of this as cotangent squared x minus cotangent x minus 2. And then ask yourself, can this be further factored? And the answer is yeah. If you had a squared minus a minus 2, you could write this in that structure. It's just a quadratic that we can factor. So that would be, that would be my further factor. Completely factored form, I believe. Okay. All right. Let's move on and finish off the rest on these pages. So starting with number 6, again, ask yourself, do I see a structure there that I could probably factor? And hopefully you're starting to get a little bit more comfortable and you see that this is really just a quadratic again, right? So we can look at this as, again, if it helps you to do this, maybe you want to write it like this, where a is equal to sine x here. And if I wanted to factor this, I would say, okay, this is a squared minus 2. Actually, you know what? Make it even easier. Why not just make a be equal to sine squared x? That allows you to write it like this. And that should hopefully be a little bit easier to factor. We can say this is a minus 1 times a minus 1, or a minus 1 squared. So if you just substitute the sine squared x for a, then you could just write this as sine squared x minus 1, that entire thing squared. And again, you don't have to simplify here, but if you wanted to simplify, if simplifying, sine squared x minus 1, you know, is equal to cosine squared x. All of that squared, which then just gives you cosine to the 4th x. Actually, I don't need the parentheses. There we go. Okay, but if you were just factoring, you could have left it at sine squared x minus 1. All right, number 7, let's look at this. Number 7 has 2 tangent cubed x plus 11 tangent squared x minus 6 tangent x. All right, so obviously the first thing we probably want to do here is to factor out a tangent. Okay, and this here should be a factorable quadratic. So we should have, let's see, 2 tangent x. This should just be tangent x. And I want there to be I want my 2 factors to result in 6, but I need 11 in the center. So this is going to be 6. That's going to be 1. Make this positive, make that negative. And there we go. We're completely factored. That's all there is to that one. Okay. And number 8. Let's move on to number 8. So this is our first one that we're looking at that's in a while that doesn't have a quadratic structure to this polynomial. But if we refer back to our notes up here about any possible strategies for factoring, one that we haven't really done yet is factoring by grouping, option 4. So if we go back down and look at this, can I factor by grouping? And I think so. If I go ahead and group these 2 terms together, make that positive, and then group these 2 together, then let's see how that would look. We have secant squared x that I can factor out of the first 2 terms, or the first grouping. That's secant x minus 1. And then from the next one, in order to make that positive secant x minus 1, because remember, we're looking for a common factor, I could factor out a -1, and we're left with positive secant x minus 1. So now that I have a common factor here, we can then factor that out, secant x minus 1. Let's put that factored out. And what's left over on the inside? We've got secant squared x minus 1. Okay. I didn't really need the brackets, but I just wanted to really distinguish what we were factoring out. Is there anything else I can completely factor? Yeah, I think we can factor out that quadratic now as just a difference of squares. So secant x plus 1, secant x minus 1. And if you wanted to rewrite that, you could do that. Secant x minus 1 and make that secant x minus 1 squared. Yeah?
Mr. No, couldn't you simplify that to tan squared x?
Yeah, so again, if we were simplifying, then I could do that. But right now I'm just focused on the factoring.
Okay.
Mm-hmm. So yeah, there are a couple of these here that I've done previously that if I wanted to continue simplifying, I would change up a little bit. Okay. All right. So hopefully that gives you a pretty good sense of how to factor some of these. And now let's go right into simplifying. So let's just finish these up here, and then I'll pause the video so we can practice rewriting in a second. So let's try these. All right, so now we're getting to kind of the shackles are off. We're not just looking at factoring anymore. Now we want to try to get this into the most simplified form. And I know how frustrating that last part of the lesson might have been, because we're so used to wanting to simplify. So now we can actually just simplify all the way. So let's see what we got here. So starting with the first one, sine t plus cotangent t times cosine t. All right, let's do a little bit of rewriting first. So sine t plus cotangent t, I know, is the reciprocal of tangent. And tangent can be expressed in terms of sine and cosine. So cotangent t can be written as cosine of t over sine t. Now, the reason I'm doing this is because I know that if I'm trying to simplify, I want to try to rewrite the terms as much as I can, or rewrite these functions in terms of the fewest number of trig functions as possible. That way I can do a lot of simplifying and dividing. So if we look at this here, this next one would be sine t plus cosine squared t over sine t. And then ask yourself, okay, well, if I want to add these two fractions, I need to have the same denominator, meaning I need to multiply sine t by sine t over sine t. So make that sine squared t. Well, that results in sine squared t plus cosine squared t all over sine t. And that would be equal to, using a Pythagorean identity, that's 1 over sine t. Oh, and that cleans up really nicely to cosecant t. Okay. All right, let's try number 2. Number 2 is going to be really, really similar. We've got 1 over sine t minus cosine t. And again, cotangent t, I'm going to try to rewrite in terms of both sine and cosine to see if it might help me reduce or rewrite. That looks too much like cost. I'm just trying to really accentuate that there. All right, we got what? 1 minus cosine squared t over sine t. And since I already have sine t in my denominator there, these are ready to add. So I'm just going to go ahead and extend this out. And then move this over here. Oops. Let's just rewrite that. And what is 1 minus cosine squared t? That should be equivalent to sine squared t over sine t, which we can then divide out to just sine t. Okay. All right. All right, let's try number 3. 3 looks like a pretty massive one here, but actually it's not going to be too bad. It's going to be a bit of writing. I'm not going to lie to you. It's going to be a little bit of writing, but it's actually not too bad in terms of simplifying. So the fact that we have these two fractions, before I want to add them together, I always want to see if I can simplify anything before I add. If so, that would make my life so much easier. But unfortunately, I don't think there are any identities I can apply just yet. Okay. Although, you know what, I'm looking at this now and I'm wondering if this, I've never actually done it this way before, but I'm trying to see if I can do this. Okay, you may not need to write this step, but I want to see if this works. Sine x over sine x just occurred to me. I could maybe do this. Does everyone see what I'm doing there for that first one? So I'm doing sine x over sine x plus cosine x sine x plus sine x over cosine x minus cosine x over cosine x. Well, we know this is equal to 1. This is equal to 1. So right now, just right off the bat, I've got a 1 minus 1. These are going to negate one another. Now, what do we have? We've got cotangent x plus tangent x. Well, I think we can actually make that even simpler because right now we have two terms and my goal is to try and write this as a single term. That would actually make it the simplest possible. So there are a couple things that we can do here. So as long as we remember that this is, let me actually just change the color for that so you can see that these are the same. But we're going to try to need to find a way to add these two together. But I think we already made our lives a little bit easier because adding these two terms is much easier than what we were trying to add before. So we need to have the same denominator. So cosine x over sine x, I need this to be multiplied by cosine x, cosine x. Okay? And I'm adding this to sine x, cosine x over cosine x. And then this time now I need to multiply by sine x, sine x. Okay? So I'm going to continue this over to the side. What does that give me? This gives me cosine squared x plus sine squared x all over sine x, cosine x. And the sum of those two would just be 1. Now I've got 1 over sine x, cosine x, which if I really wanted to simplify this all the way, I would be proper here and write this as cosecant x, secant x. And that would be our final answer. So we've done a pretty good job, I would say, of simplifying this all the way down to cosecant x, secant x. Okay. So hopefully you're a little bit more comfortable now with simplifying, factoring, just using identities to rewrite trigonometric expressions, because that's going to be really critical for us to work through verifying. Okay.